throughout the review, and we'll just like do it as is.
Yeah.
Yeah.
Save some time.
Yes.
All right. If you guys want to get started, I'm going to use the bathroom really quick. I'll be another 30 seconds. I just wanted to get on so that way you guys knew I was here. I'll be right back. Okay.
So I was reading through part 2. So, and I have the data pulled up. Do you want to start reading through that while he's in the bathroom? Are you ready, Justin? Is everything good on your
Yeah, I just don't have my SPSS's. We're having difficulties with it. It's starting to pull up.
So,
There we go. Okay, so what do you want to do?
I just wanted to go ahead and start so we can knock this out because there's nothing like.
Yeah, let's start.
So, has everyone read the first paragraph? You don't have to read it all out, right?
Yeah, I've read it.
You good, Ashlyn?
Yeah, I'm ready. I'm almost done. Okay, I'm good.
So it says, what is the research question? So I think that they're trying to figure out, because of how the null and alternative hypothesis is set up for these types of variances, that is the mean age at death different from any other of the categories, I guess, right? So it's not like, is it higher, is it less, it's just, is it different? And
Right.
if one or more of them is different, then we have what we're looking for to reject the null.
Yeah, that's what I have written down from when I did it earlier.
So then we have to go into the data, and I'm not exactly sure if mine's going to be the same way. I have it all pulled up, and it looks like it separates everything so much. So for the first type, which they said was novelists, we had 76, like N, the sample size was 76. For poets, they had 32, and for nonfiction, they had 24. And let's see. The mean for the first one was 71.45. For the second, 63.19. And the third one was 76.88. So I think we need to write all of that down, right? Anyone looking at the answers? Check me.
Is this for B?
Sorry,
state
what was
no?
that?
Oh, sorry. So I was skipping ahead. So we got the first A is exactly what we said it was. State the null and alternative hypothesis. In my notes, it just says that HO is all the means are equal, and HA is one or more of the means differs, pretty much.
And that's going to be the same answer.
So when I read it, and I just confirmed it with the answers, they don't really see how they decided to pull subsets for this, like how they, if it was a simple random sample, or they don't really say. Did you guys see how they picked it?
Yeah, I'm back. Sorry.
No problem.
Which one are we on?
Part 2, number 3. Or 2, sorry.
Pulling up my SPSS stuff. Just doing the remote client though, so it's slow.
Oh. So it says, I'm rereading in here, it doesn't say anywhere like how they gathered the data. So I'm not sure if that's going to be a problem or not, since in part of the is talking about how it needs to be an SRS in order for it to be valid, but so they don't know.
Oops.
But for number 3, we're all there. Group 1, which was novelist, the N equals 67, and I got a mu of 71.45. And for group 2, n equals 32, and mu equals 63.19. And then for the last group, it was 24, which I think was the nonfiction writers. And mu equals 76.88. I don't really see how it totals for like what our overall one is. Maybe we don't see that. Anyways, I think that's all the data we needed for that because
I think so.
a histogram on my end, so we have all of that.
No more, Mason.
So, what type of hypothesis test is appropriate? So, obviously, we're going over ANOVAs,
Yeah.
and there's more sample groups, so you couldn't use the independent or whatnot because it's not a pair, so we'd have to do ANOVA. And then, what are the requirements for this test? Well, I kind of just went over that. I didn't say anywhere that the groups could be larger than 30, but it says in the answer that it could. Did you look at the PowerPoint? So,
I don't remember it saying it had to be.
I wrote down 4. That the samples are an SRS. Samples have to be independent. The populations have to have the same data. So we're supposed to take the largest standard deviation, and then the largest one can't be 2 times greater than the smallest deviation. And then you have to make sure it's normally distributed using QQ plots. But it doesn't say anywhere in there that I saw that if the sample size was larger than 30, that qualified. Did you guys see that anywhere?
I don't remember that, and I'm looking on the textbook online, and I don't see anything about that either.
Because I'm looking at another thing, and it says the data are normally distributed for each group. For the first 2 groups, the sample size is greater than 30, so we can assume normality. So I guess that CLT just applies by default because of that rule, but it didn't say that in the text. And then it says for the 3rd group, the students would need to make a QQ test for normality. So I'm gonna check it really quick.
It's not affecting me.
I feel like it's I mean, it's supposed to go like straight to QQ.
What is going on?
Whoa.
So if I do this right, it looks like it has a normal distribution. But I think it tested for all the data, not just group 3. A little bit of a lot. You know, if there's any way, Justin, just to test one group?
I don't. I just know how to do all 3 of them, and it'll bring up the QQ plot for the 3 separate. It doesn't put all the information in one QQ plot. It'll bring up 3 separate QQ plots.
So tell me how to do that, because I did analyze descriptive statistics Explorer, and it didn't give it to me, and so I did descriptive statistics plot and it's just 1.
Okay, so you move. You're going to move one variable over to the dependent list,
Okay.
and then you're going to move the other variable over to the factor list.
Now, do I just do type for the factory list, or do I have to do what I transformed in the encoding?
Say that again. I couldn't hear you. There's something going on in the background. I can't.
Yeah.
I transform the data. Do I need to use the one that I created, or does that make a difference?
I wish my SPSS was working. We had a storm go through here today, and it screwed everything up.
Sorry. I can't get the data file downloaded. It's having errors on the virtual client. I'm sorry. Otherwise, I'd be there with you.
I have it. I just don't know. I just don't see a histogram for, or not a histogram, for just that one data.
The double. I got it working.
All of it. I just don't know how to get that one. And I wrote down the
Yeah,
direct.
because when I did it, so is there two different variables you can move over?
So when you're talking about when I go to analyze descriptive statistics and then explore, right?
Yeah. Then what's over on the left hand?
Any histograms, or not histograms. I don't get any Q plots when I do it this way. I only get it when I actually go to QQs. I can only get stem and leaves and histograms with this one. Oh, look, normality plots. Never mind, I figured it out. We're good. It is in QQ, so I wasn't looking. I didn't see it. Okay, so it still only has 2, and one's for everything on the close normality, and then one that's totally not normal. It still says it's for 1. Ugh.
Yeah, I know. I almost had it, and then now it's like freezing.
Oh, I got it. It's working. So it is normally distributed. It's kind of weird because it kind of dips a little bit in the middle, but I think it would still be considered normal. I wish I could show you guys.
Are you doing like the means plot?
No, I did a QQ plot. I just didn't use my separated data. I used just what was in the input, and it separated the 3 different types for us. So the first 2 are quite obviously normally distributed. This one is, I'm pretty sure it's normal. I think you guys would agree. So the requirements for the test is that it has to be normally distributed. Sounds like someone's sandpapering. The samples are independent. I'm assuming it's a simple random sample. And the standard deviations I have on here too, so I'll check that really quick. So the standard deviation, I did so many of these graphs that I can't find what I did. One second. I just had them. Okay, so the standard deviation of 1 is 13.052. Group 2 is 17.297, and 3 is 14.097. So if you double, they're also close together that it qualifies. So this
The standard deviations?
Yeah.
Okay.
Yeah, so you go the 13.052 times 2. So the 17.297 is definitely smaller than that.
Yeah, but they're all pretty close together though. 13, 17, and 14. None of those are double the size, so we're good. Okay. So then we're good for B, right? 4B.
Yes.
Yeah.
Perfect.
And C too, right?
So let's see if I can find the F statistic. I'm sure it's on here. F
Should be this.
6.536 or 6.563.
6.3.
Is that right?
Yeah, that's right.
So our degrees of freedom, the first one's 2 and the second one's 120. So we always use the second one, right?
That's what I was confused about, because on
Yeah.
what was it? On one of them, they showed that you just use the second one, and then I think on this one, if you look at the answer key, it says 2 and 120. Because the 2 is going to be your denominator, and 120 is going to be the numerator, from what it was explaining in the video.
I thought it was the other way around. I thought 2 was the numerator and that 120 was the denominator.
Oh, you're right. Yeah. Sorry, I said that backwards.
No, you're fine. I wrote down that the top one, the between groups, that shows up first in SPSS, is the variation among sample means.
Right.
So it's not as useful in this instance, but the within group is variation among individuals in the same sample. So it's not. That one seems like it's more applicable to what we're doing, right?
Right. Yeah.
So you guys have this thing up, right? You got the right answer. I'm pretty sure we did. What does it say in the homework?
Look at the
120. So I think we're doing good. So for E, it says compute the E or the p-value. According to my SPSS, I got 0.002.
Yeah, that's what I got earlier.
What was it? 0.00 what?
2.
2.
And that is smaller than the alpha, which is the level of significance, which is 0.05.
Yeah.
So we would reject. As usual. I feel like they love rejection sometimes. And then we have sufficient evidence in order to reject it. We have sufficient evidence to say that the means are different. Right?
Yeah.
Yep.
So do we want to go ahead and take this quiz?
Sure.
let's give it a shot.
This will only work if SPSS is working for at least one of us. So everybody cross your fingers.
Yeah, mine is, so I finally got the data file downloaded and I have it up and everything. And so I've been just trying to listen and follow you.
I totally understand. That was me last week, so.
But hopefully for the quiz I can be up to
And we need you to be the reader because I just skip the reading and make everyone do it in their heads.
I will read. I will also do my best to keep up with you. All right. Group E, L14. There we go. Number 1 and 2 are easy. There's only 15 on this. That's good.
It's good.
Sweet.
The next one will be long. It'll be like 30 though, most likely. Let's see. Question 3. You guys ready?
Yep.
Okay. Question 3. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others.
Yes.
True.
Awesome. I love true and false questions.
Me too. I wish they were all true and false.
All Actually, we've got a lot of these where we don't have to enter information. Like only 5 to enter information. That's pretty cool. All right, 4. What requirements need to be checked when performing an ANOVA hypothesis test? The sample means are all positive. Data in each group are normally distributed. Variances are equal in each group. None of the above, or B and C.
B.
I feel like it's more than that.
I
So
think it's B and C, isn't it?
I'm reading through my notes really quick. So it says for ANOVA analysis of the variance, compare sample means, and it talks about kind of. Hang on.
I don't think that the means have to all be positive, because that would make sense.
So it's confusing the fact that there's something else that's always positive. Hang on, I'll find it. I wrote it down.
So I have written
Groups have to be
down.
normally distributed, right?
Yeah, see.
And then the variances have to be equal in each group.
So I have written down the values of F are never negative.
That's
And
what I wrote.
then I also have the variances are equal for each group.
Perfect. Let's do B and C as our answer then.
Definitely, because it's not the sample means that are all positive. It just
Yeah, it's just.
That just sounded funny, because what if you're just testing something in the negatives? You know, they're going
Yeah,
to
see,
be.
that's what I thought.
It's just
Yeah, definitely.
that's not a rule. That's
B and C.
I hate tricky questions sometimes, you know?
Mm-hmm.
It's the whole F question, and then it's... All right. 5. To check if each group is normally distributed, do the following. Construct a scatter plot of the data, histogram or a QQ plot.
QQ.
Now, if n is over 30, you don't have to. You can just assume it's normal, right?
They didn't say that in the notes, but they did say it in the homework. So I'm assuming you can just always claim the CLT rule and you'll be covered.
Yeah, that makes sense. Okay. 6. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest group sample standard deviation is less than 2 times the smallest sample standard deviation. That was a mouthful. The largest sample mean is less than 2 times the smallest sample mean, and each group has the same sample size.
I think the third one, right?
That's what I thought.
It is check if largest standard deviation is no more than 2 times the smallest standard deviation.
Oh, yeah. So wait. So the sample
Oh, wait.
sample mean, that's not the standard deviation. Though.
No, sorry.
Oh, hang on. No, it got me too.
So that would be the second one. The largest sample standard deviation is less than 2 times the smallest sample standard.
Yeah.
That's exactly it.
That's the answer.
Mm-hmm.
Going good so far, guys. All right. In an ANOVA hypothesis test, an ANOVA hypothesis test is equivalent to conducting independent 2 sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs: 1 and 2, 1 and 3, and 2 and 3. How many pairs are there when there are 4 samples?
I feel like this is a trick question.
Well, let me write it out and figure it out.
Yeah, that's what I was going to say.
If you just wrote this out, I would assume, and you'd be fine. Okay. 1 and 2, 1 and 3, 1 and 4.
Is it 5?
2 and 3, 2 and 4,
So I got 6
3 and 4.
because they're right.
Yep.
6.
You're right, there's 6. I wrote it out.
What are they? I missed one. I didn't write it out though.
1 and 2, 1 and 3, 1 and 4.
Yeah.
And 2 and 3 and 2 and 4, and then 3.
Oh, okay.
Mm-hmm.
Got it. And I said 2 and 3.
So 6 pairs.
Say pairs, or can we just write 6?
I just put
How many
6.
pairs? I would just put 6.
Okay.
I'm just putting 6.
Number 6. 8. The soccer shoes data has 6 groups: A, B, C, D, E, and socks. These data can be found in the wiki. Load all 6 samples into the quantitative inference procedure spreadsheet, or perform an ANOVA test in SPSS. So ANOVA test in SPSS, and observe that the p-value is 0.08. Excuse me. The p-value
Bless you.
thank you, is 0.0809. Remove the socks data. What is the p-value?
I'm loading the list right now.
What was it called? It's called soccer shoes data. Okay. Yeah, I got the data, and then we do an ANOVA test, right?
Yeah.
ANOVA.
So how are you guys loading up the data?
Okay, I have it up. So, did you load it from the reading list?
That's right.
Doing
Just
the footwear and
okay.
accuracy.
Okay, so I have. We just need the p-value. It's 0.081.
That's with socks. So then it says to remove socks.
How do you remove socks?
I would just manually delete it.
Every time I manually go into stuff and it jacks it up.
It yells at you. Oh, that's fun.
Hey, keep that p-value you got without removing socks, because number 9, it'll ask us about the p-value with socks and without socks.
Okay, I'll try to see if I still have it. I'm pretty sure it was 0.081.
What did you say it was?
With the socks, it was 0.081. Without the socks, I got 0.309.
0.039.
0.309.
0.309.
How did you do that, by the way? Yes.
You get the data.
So you analyze, compare means, one-way ANOVA.
The first thing I did was I transformed the description group.
How did you do that again?
I went to transform and then automatic recode and then clicked on the one that had letters in it, which is the footwear.
Okay.
And I renamed it to Footsie, which you can name it whatever you want.
Footsie works. Okay.
And yes.
Add new name.
So then you add that, and then I went to analyze, and then you always, something I got out of the videos that I thought was really helpful is that, let me get to where I was. In the dependent list, you always put what you're measuring, and then in the factor list, you always put the grouping. Or it says, hang on, how did I write that down? The grouping. variable. Because I think I was getting them backwards a lot.
Yeah, that's what I was getting backwards in there. I realized that same thing.
Because I kept getting that string variable issue. So. Okay, so what's the first question on the quiz?
And how did you figure out the p-value after you did that again?
It's just right there. And it's called the sig.
Oh, 0.08. Duh. Okay. Thank you. 0.081. Okay, and then let me remove number 6, correct?
I removed all of the things that said stocks. Right? Isn't that what I wanted? Yeah, remove the stocks. And I got 0.309.
0.309. You're right. Wow. That's cool. Thank you for showing me, by the way.
Yeah, of course. That's what we're here for, right?
Yes, thank you. Okay. 0.309. Okay. The value always goes up when only one group is removed compared to the p-value. Is that true?
I don't think so. It depends on what values you were taking away, doesn't it?
That's what I would assume. But according to the last, according to our SOC data there, it did.
Well, I think maybe that's trying to trick us. So should I redo the data again and see if I delete a different one, if it goes up still?
Yeah, try that.
Okay, let me see if I can reload it with everything in. This time I'll just delete all the A's. Right? That sounds pretty easy.
Sure. I feel like it wasn't covered necessarily. Can't find that.
Well, I'm trying it right now, so let's see what I get. So I just deleted A, and it changed to 0.060. So obviously...
Got to be false then.
Yeah. I mean, it really depends on what the value is.
Yeah, it's not always going to go up.
Yeah, it depends on what the values are that you're deleting.
So false.
Oh, no. Now for 10, you're going to need to delete.
Mm-hmm. Yeah, so what is the highest p-value you see when removing only one group?
Oh
You'll need to compute an ANOVA for each possible option.
It's like no one could get 9 wrong then.
Yeah.
Okay, so when I deleted A, we got 0.060. And then when we deleted E, or socks, we got 0.309. So that seems pretty high. So let me see what happens when can I just add the data back in, or do I have to do this long process every time I want to do this? No. Okay. Cool. So I'm going to delete B now. Man, I must have had such a great idea, huh, guys?
Well, here, I'll do C then.
Okay. So when you delete B, It's 0.052.
When I got rid of C, it gave me 0.448.
0.0448?
0.448. Let me delete it.
That's our largest value so far.
Yep. Let me go a step back. Okay. You want to do D and I'll do E?
Yeah, I'll do D right now.
Okay. Okay, I got 0.050, so
I'm almost done.
if you select like 1 over, so like you start at the top of, like, say you're getting rid of D, you select the top of, like, the top left D, and you go down to the bottom right. You have to drag all of it, right click, and you hit clear, and you get rid of all. And then if you want to hit that green back arrow, that'll undo what you did after you've analyzed it.
Okay.
If you wanted to try it out,
Background.
it'll save a little bit of time.
I got 0.013.
What'd you get?
0.031.
Okay, so 0.448 is our highest then.
Yeah.
Okay. When all 6 samples are used, what is the minimum smallest standard deviation?
0.0331. Oh no, wait, standard deviation. Gosh. I'm still thinking.
Smallest standard deviation out of all of them?
Hang on. No, that's not.
Is it out of all of them or combined?
How do we get separate standard deviations?
Well, you can see the separate deviations when you compute the statistic through the ANOVA test.
I don't see a standard deviation though. There's the sum of all squares and the mean square.
Under descriptives, did you check some descriptives under options when you analyzed it? That it'll show you. So go back to the data, hit analyze, compare means, one-way ANOVA. And on the right-hand side, you got the 4 boxes. Click options. Click on descriptive, and also click on means plot.
Yeah, I didn't even know to do that.
What
And
else
then,
did you click on? Because I got down to put descriptive, but what else did you click?
You can click on means plot. It'll just show you the plot of the means
Means
and how
what?
they compare to each other.
Okay.
Okay.
So I have all of them besides D, because apparently.
Go back to your data,
Okay,
and then just click the back green button. I guess I don't know. I'll let you.
mine keeps giving me an error code with that, but I'm literally just gonna do it one last time, and then hopefully we'll be done with it.
Are we just looking for the smallest standard deviation out of all of the different ones?
Yes.
Yeah, and then we'll need the maximum for the next one.
C is 5.216.
5.216?
Yep.
So that's for the smallest?
The smallest standard deviation. Now the largest is
I can get that. That's not even on. Oh, yes, it is. Never mind.
Yeah.
Just kidding.
Okay. D is the largest at 7.291. Okay. And then when the test for equal variances is satisfied for these data, look at variances.
I'm pulling mine up right now, sorry.
Okay. The variance. What is the variance in relation to the standard deviation again? Know how we get it?
So it's so you take the largest standard deviation,
Uh-huh.
and it has to be less than 2 times the smallest standard deviation.
Oh, okay. So in this case, the test for equal variances is satisfied for these data. True. So it is true. It is satisfied. Right?
Yeah.
5.2 and 7 point whatever. It's not gonna. That's not double.
I just did the QQ plots for the next one, and A is definitely normal. Some of these it's like hard to kind of tell. B is kind of weird, but it could be normal. C is definitely normal. D is definitely normal. E is definitely normal.
Another plane coming by. Can't hear you.
I don't
What's that?
So all of them I'm pretty sure are normal besides B.
Besides B.
Yeah, I don't know if B is or not. It could be, but it's just kind of weird. Like the first value lies below the normality line, and then the next few kind of curve above it, and then the next few kind of curve below it, and then the last value is right above it. I don't know.
Is it like super spiky, or is it just like a slight like curve?
It's like a weird, like long S. It's like kind of like a snake's wrapped around it. But
Do you think if Victoria shared her screen, just her, we would be okay? Because then we can all see it if she would just share her screen.
I don't know how to share my screen though. All I know is how to show my face on my camera.
If you go to your Google, on the side, you'll have a little menu, and it's a little green one with a, it's like a little green TV, or I guess it's a computer with a white arrow.
Okay. Do you think that's gonna make it lag?
I don't know, that's what I'm wondering. But maybe that's just one person for a
Right.
short time.
Try it really quick, just enough so we can see. Make sure it's all set up, and then we'll just when we're good,
Do I
we'll
like
say.
turn it off when I'm done? Do I just click it again?
Yeah.
Okay. So here we go. Oh, it brought me to something else. What do I want to show you? Can you guys see that?
Yes.
Yep.
So here's A, and there's B.
I'd say that's normal.
I think that's normal. There was one like that on the, I think, one of the videos.
Yeah, I'd say this.
There's C. Looks really good.
Especially if you were to mesh all these together, it would definitely appear normal.
Yeah.
Okay.
Okay.
Out of it.
Thank you.
No problem.
True. Then for 15, the test statistic for an ANOVA hypothesis test is the F statistic. Is the p-value the area to the right or left of the F statistic? The right.
Well,
Wonderful.
actually, so it says on here, it always confuses me because it looks like it's to the, oh no, that's right. Never mind. We're good.
Yeah, it's always right skewed.
For some reason, I transverse that in my mind because I'm like, well, I'm looking at it, and that's my right, so it must be the left. It's because I work in the medical field, and I'm always looking at what side of their body their heart's on.
We got 100! Yay!
I'm going to go ahead and post this, guys, okay?
Okay.
Awesome.